Good morning, children. Today's topic is chapter 15, probability. A dice is rolled number of times and its outcomes are recorded as below. Outcomes 1, 2, 3, 4, 5, 6. Frequencies 35, 45, 50, 38, 53, 29. Find the probability of getting a number 1, number 2, number 3, 4, 5, 6 and find the total probability of each event. Already we have started the concept of the empirical probability or experimental probability. This time a die is rolled, the number of times is given. Now they are not given what is the total number of times. So what is the first step in the solution means we should write, because many sub questions are there. So all the sub questions there is no need of writing the formula. So we will write that for any event E, P of E equal to number of trials in which event happened divided by total number of trials. Because many sub questions are there, the first only we are going to write the formula for any event E. Which probability we are learned today? We are learned empirical or experimental probability. P of E equal to number of trials in which event happened divided by total number of trials. Now what is the next step? So the first sub question, probability of getting a number 1. Like this we should write a probability of getting a number 1. Before that, it is common for all the questions, which is common total number of trials. So we will write a total number of trials equal to, we should add everything, 35 plus 45 plus 50 plus 38 plus 53 plus 29. If we add, you will get a 250 only. Now getting a number 1, which is the number favoring to that 35 divided by 250. Now if you are not writing the formula first only, we should write for each sub question the formula, repeated formula. That is not required. One first only write and keep the formula, then according to that you substitute. Now what is the question number 2? Getting number 2. So how many are favoring number 2? It is 45 divided by 250. Similarly, if anything can be cancelled, you can cancel it. A simplified answer only, because it's a 5 multiples, you can cancel. If it is go for a 7 by 50, like this, 9 by 50. If you want you cancel, but better always can simplified form only we should write. P of getting a number 3. Like this you continue, that is 50 by 250. Again D, P of getting a number 4. It is equal to 38 by 250. E, getting a number 5. It is equal to 53 by 250. F, P of getting a number 6. It is equal to 29 by 250. Now the last question, it is asked that total probability. Total probability, that is G only. Total probability of each event. That means we should add everything. That is 35 plus 45, 35 by 250 plus 45 by 250 plus 50 by 250 plus 38 by 250 plus 53 by 250 plus 29 by 250. You already know that this frequency only we have added and we got 250. So what is the numerator? 250, and the denominator is also 250. So what is the total probability for this event? It is equal to 1. A dice is rolled a number of times and its outcomes are recorded as below. Outcomes 1, 2, 3, 4, 5, 6. Frequency 35, 45, 50, 38, 53, 29. Find the probability of getting an odd number. So we'll write here number of Number of trials in which odd number happened. Which are the odd numbers? 1, 3, 5 only. So 35 plus 50 plus 53. So 138 are favorable to the event. So total number of trials, what we should do? Total number of trials means we should add all the frequencies: 35, 45, 50, 38, 53, then 29, you'll get 250. So what we should start now? Let E be the event denoting getting an odd number. Therefore, P of E, or we can write that P of getting an odd number. So P of E, or we can write a P of getting an odd number. Number of trials in which event happened divided by total number of trials. So how many events you got favorable there? 138. So 138 divided by 250. If you cancel with the 2, what is the answer? 69 divided by 125. Then further simplification is possible, we can do, otherwise we can keep like this only. Now what is the question? Number of trials in which the odd number is getting. So odd number cases we have added, that is 138, and the total number of cases it is 250. Out of 250 trials, the 138 is the favorable one, right? Out of 250 trials, 138 is the favorable, so 138 by 250 is the required answer. The probability of guessing the correct answer to a certain question is x by 3. If the probability of not guessing the correct answer is 1 by 3, then find x. This question we have to follow the sum of the probabilities. So we know that probability of guessing correct answer plus probability of guessing non-correct answer or wrong answer equal to 1 only. So both are complement event, guessing correctly and guessing incorrectly. So here x by 3 plus 1 by 3 equal to 1, x by 3 equal to 1 minus 1 by 3 equal to 2 by 3. So x by 3 equal to 2 by 3. So x equal to 2 by 3 into 3 equal to 2. So sum of the probability is equal to 1 concept we have to use and substitute and get solve for x. Next question. In a survey of 364 children, it was found that 91 like to eat chips. If a child is selected at random, compute the probability that he or she does not like to eat chips only. Does not like to eat chips. How many are like to eat chips? 91. So we will write here that total number of children or total number of trials for us here. Total number of children trials means total number of children equal to 364. Number of children like to eat chips equal to 91. So number of children does not like to eat chips equal to 364 minus 91. So for any event E, what is the empirical probability? By empirical probability, P of children does not like to eat chips equal to number of trials in which, what is the formula that we should write first, in which the event happened, divided by total number of trials, equal to 273 divided by 364. So this is the answer, 273 by 364 for the number of children who does not like to eat. In a medical examination of the students, the following blood groups are recorded. Blood group A, AB, B and O. Number of students 10, 13, 12, 5. A student is selected at random from the class. Find the probability that he has a blood group A. So our favorable is A only. How many A are getting there? 10. Now we don't know total number of students, just add and see that one, total number of the students, that is a trial for us. So solution, total number of students or total number of trials equal to total number of students. Equal to 10 plus 13 plus 12 plus 5. Then 13 plus 12, 25 plus 5, 30, 40 are there. Okay. Now number of children, students only word is used. So number of students having blood group A. Now we have to write it by empirical probability. P of E equal to, formula first, number of trials in which the event happened divided by total number of trials. So 10 by 40 equal to 1 by 4. So it's a favoring divided by total number. So it is 10 by 40, it is equal to 1 by 4. The record of a weather station shows that out of the past 250 consecutive days, its weather forecasts were correct for 175 times. What is the probability that on a given day it was correct or it was not correct? So here the solution starts now. So what we should write, a total number of trials equal to 250. Number of times the weather forecast were correct, we'll write equal to 175. Not correct, 250 minus 175. 75 times. Now what is the formula we will write? We will write the first formula only. Probability of any event E. It is number of trials in which event happened divided by total number of trials. So the first one, it was correct. So P of getting correct equal to 175 divided by 250. What is the sub question when it is not correct? Weather report not correct. 75 by 250. Simplified answers respectively 7 by 10 and 3 by 10 only. So when we are not writing this event E, that is a formula we have written, we are writing P of getting weather report. Here I should write a weather report correct. Equal to 175 by 250 and 75 by 250. I would just want to tell you that when sub questions are there, formula to be written on the top, and then you can do directly the value substitution in that. There is no need of writing for each sub question the formula again and again. So it is the experimental probability, it is easy only, just to find out the frequency and then total number of trials. Following frequency distribution give the weight of the 38 students in a class. So weight in kg 31 to 35, 36 to 40, 41 to 45, 46 to 50, 51 to 55, 56 to 60, 61 to 65, then 66 to 70 and 71 to 75 respectively. The number of students are 9, 5, 14, 3, 1, 2, 2, and the last two groups 1 each. So find the probability that the weight of the students in the class is at most 60, at least 36, that is the second question, and not more than 50 kg. So what we should write means total number of trials we should write first. So the solution, total number of trials, or we can say that it is equal to total number of students, equal to 38. If you count that one, you will get 38 only. 9 plus 5 plus 14 plus 3 plus 1 plus 2 plus 2 and then plus 1 1. So it is equal to 38 we got. Now we have to know that what is the utmost value. Before that 3 sub questions are there. So what we should write? We should write the formula. For any event E, so for more than at most 60 is the question, that is the maximum value is 60. So because sub questions are there, so what I told you that write the formula for first only. For any event E, the empirical probability P of E equal to number of trials in which event happened divided by total number of trials. So what is the first sub question? It is at most 60. At most 60 means maximum is 60. So we'll write here at most 60 means 60 or less than 60. See, 60 is maximum. So up to here whatever is there, we will get a total frequency. So that is favorable to here. So number of students whose weight is at most 60 kg equal to 9 plus 5 plus 14 plus 3 plus 1 plus 2. It is equal to 34. So P bracket probability of students whose weight is at most 60 kg. 60 kg, okay, 34 by 38. Simplify means it is 17 by 19. So what is the meaning of at most 60? It is equal to maximum value is 60 and less than 60 is possible. All are favoring to that one. What is the second question? At least 60. What is the second question is at least, 16, 36 kg. At least 36 kg. That means 36 and more than 36. So what is the values favoring there? That is 5, 14, 3 like that. So we will write that 5 plus 14 plus 3 plus 31, 3 plus 5 plus 14 plus 3 plus 1 plus 2 plus 2 plus 1 plus 1. So it is equal to 5 plus 14 plus from here onwards 3 plus 1 plus 2 plus 2 plus 1 plus 1. It is equal to 29. Now what we should write? P bracket number of students whose weight is at least 36 kg, at least 36 kg equal to 29 divided by 38. 29 divided by 38. So we got the answer here. What was the previous question? It was at most 60. That means maximum is 60 and less than 60 is possible. Here what happened? Number of students at least 36 kg. So 36 and more than 36. Now one more question is there. What is that question? Probability of getting the students between not more than 50 kg. Third question. Not more than 50 kg number of students, right? Number of students whose weight is not more than 50 kg. Not more than 50 kg means more than 50 is not possible. So which are the favoring event for us? 9, 5, 40, 9, 5 plus 14 plus 3. See, why I have taken 3 here? More than 50, not more than 50. Whenever we are taking a class interval like this, 50 is not included there. Upper limit part is not included. That means not more than 50. 50 is not counted here. That is why we are taking this one. So 9 plus 5 plus 14 plus 3, that is equal to 17, 22, 31 will come. Now P bracket number of students whose weight is not more than 50 equal to 31 by 50. So from here what is the count comes? 51 onwards coming. So here 50 is maximum there. So that 3 will be included. So here one point which is remember, that is at most and at least. You don't confuse the idea. Practice that type of the questions. With this today's class I am winding up. Thank you.